For our fourth question is taken from SPM trial paper, and for the first part we need to prove the formula for sum to infinity. Okay, so this is one of the sum formulas for geometric progression, or GP. Before we prove the formula, let's look at the formulas in GP. So for sum, we have two kinds of formulas, right? So one is sum to infinity and the other one is sum of the first n terms. Difference is one is infinity and the other one is n. So I'd like you all to focus on the range of R. Okay, so sum to infinity must be -1 to 1 and it's exactly the same as this one. Okay, so why is exactly the same? So I can do the mathematical calculation for you all. So now I'm going to move the modulus to the other side. So one is the positive one, which is no changes at all. The other one is I need to move a negative to the other side. So here the sign will change and then here will become -1. So what I'll do is I will switch their positions. So -1 become here, R become here. And then this one is R is more than -1, so I'll remain that sign. So here is also R is more than -1. Okay, and then if I combine these two, meaning I put the R in the middle, so it will be less than 1, but it will be more than -1, which is exactly the same as the range for sum to infinity. So what I'm trying to say here is these two actually have a relationship whereby sum to infinity formula is actually a special case from Sn, from this formula. Right, so now back to the question, how do we prove this? So I can say that, okay, we need to use Sn for this formula, not the other one. Alright, and then since the difference is only n and infinity, so I'm gonna say that when n goes to infinity and also the range of the R is between -1 and 1, Rn, which is this part of the formula, will become 0. Okay, so imagine this n, it's very big. Let's say 10k, and for the R must be between -1 and 1. So I'll choose one random value, let's say 0.5. So if you plug this into calculator, you will get 0. You can try for other numbers as well. So for example, 0.5, you can put like 0.9999, and then you put power for 100. Still, the number would be 0. Alright, so if this part becomes 0, technically 1 minus 0 will be 1, 1 multiplied a will be a. So if our n becomes infinity, technically numerator would be only a, denominator doesn't change. So you can see that this part and this part is exactly the same. So we can just say that hence S infinity equals to the formula. So here the proving part is just n to infinity. You need to write n to infinity and you need to write R is between -1 and 1. So your result would be Rn approaching to 0. So means this part will be 0 and you will automatically form your S infinity formula. Right? So for proving, not all proving need to have a very complex mathematical calculation. For this one is a bit special because you just need to explain how you got it. And for part B, we are going to use the formula in part A, which is sum to infinity. And it also says that the pendulum has a length of 20 cm. And it says that the first swing involves an angle of 70 degrees. So from here, swing to here. And the second swing would be 67.2 degrees. So from here, swing to here. And it says that the angles follow the geometric progression. So now the question tells us to find whether the total distance traveled from the pendulum exceeds 700 cm until it stops. Okay, so again, the pendulum stops, meaning we are going to use the sum to infinity to find the total distance traveled lah. But the issue is, how do I use the angle here to find the total distance traveled, right? So, assuming that the distance traveled here, this part is one part of the circle, right? So this means if we have a circle here, then the angle here is 70. So this is the part that I need to find, right? So what I can do is, I'm going to use the circumference of the circle first, which is 2 pi r. Then I'm going to include the part that I want, which is 70%, divided by the angle of the whole circle, which is 360 degrees. Then I can find my distance traveled, okay, using this formula. So there's another question, which is, we know that the angle follows a geometric progression, but the things that we need to find is actually the total distance traveled, which in the question it doesn't say that it is a geometric progression. Because if it's not, we cannot use this formula, right? For angle we can, but for distance traveled we still don't know yet. Okay, so let's do some calculation to prove that distance traveled is a GP. Okay, so the easiest way is, we are going to find the ratio of the angle first, right? So assuming that the first angle is x, okay, and then the second angle is y. So the ratio here is y divided by x, right? This is for the angle. For the distance, we are going to use the formula that I discussed just now. So 2 pi r multiply x divided by 360 degrees. The next value will be 2 pi r multiply y over 360 degrees. Then I divide these two values. And you'll notice some of the things you can cut off. For example, 2 pi r and 360 degrees. And at the end, you'll get y over x, same as the angles ratio. Okay, so this proves that distance traveled is a geometric progression, the same geometric progression. The reason is because both of the values, right, multiply and divide the same value, which is 2 pi r and 360. That's why at the end the ratio will be the same as the angles ratio. Alright? So now we have proved that distance traveled is a GP, so we are going to calculate A and R lah. Alright, so for A will be 2 pi r multiply 70, which is the first angle, divided by 360. So, and also for the R, we are using 20 because the length here, the pendulum's length is 20. Alright, so the value will be 7 and 7 over 9 pi. So this is our A. Okay, then for our R, we need to find the next value, right? Because second term divided by the first term. First term is this one. Okay, so we need to find the second term. So here 2 pi r multiply with 67.2 this time. Right? And then R put as 20, then you'll get this value. So I'm going to put this value here to find the value of R, which is 34 over 25. So now I'm going to put into this formula right here lah. So here divided by 1 minus R. So here will be 1 minus 34 over 25. And the final answer is 610.94, which means the total distance traveled did not exceed 700 cm.